Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Joining us for another Sunday's Perspectives show. Really excited about these new Sunday shows. I know we've seen some good uptick in the very first one we did last week, looking back at Andy Jassy's legacy at AWS. Today we're going to look at, and I know some of you are going to be a little took back by this, we're going to look at what happened with OpenStack. And before you turn the show off and before you say, whoa, hold on a second, I haven't heard about OpenStack in a long time, this show's going to be interesting. We're going to look at some historical perspectives, but we're going to look at it in the context of what did we learn from the OpenStack community? What did we learn from OpenStack technologies about founding, and some other things around that. So stick around for this one. It's going to be a very good show. We're really looking forward to kind of digging into what happened with OpenStack. Today's show is sponsored by BMC. And BMC wants to know, is your business on its A game? The A game is when systems are intelligent by learning from markets, where automation is paramount yet effortless, and when technology and people work as one in an enterprise. The A game is your business at its absolute best. BMC calls this the autonomous digital enterprise. Find out more at bmc.com/agame. That's bmc.com/agame. And we're back. And folks, as we said, we're going to dig into what happened with OpenStack. And I really want to look at this somewhat from a historical perspective, but not completely as a historical thing. We don't want to just talk about history. We want to look about what did we learn? What did we take away? What worked? What didn't work? And for those of you that are somewhat familiar with OpenStack or not familiar with it, it's a technology that's still around today. It's still very viable, just not in the place that it was when it got started way back in 2010 and 2011. So let's get started with some basics. OpenStack was designed. It originally came out around 2010, 2011-ish timeframe, maybe a little earlier than that when it was first being worked on. But it originally started as two projects. There was a storage project that was going on at Rackspace that eventually became called Swift, and there was a compute project at NASA that was called Nova. And at some point, these two projects got together. We'll talk a little about the history of what went on around this. There's lots of versions of the history at this point. But the two of them kind of got together and they said, hey, we should combine these two together. We should work on building an open source programmable cloud infrastructure and put that out, and we'll call it OpenStack. And so OpenStack got started, like I said, around 2010-ish. There was some earlier work just a little bit earlier than that. And basically what they were trying to do was trying to create API-defined, software-defined infrastructure. So, at the time, there were a couple of other projects going on at the time that were doing similar types of things. The Eucalyptus project was out there. It was trying to very much be a complete replica, open source replica of what AWS was doing with their APIs. There was also another project called CloudStack that was out there that had been started by a company called VMOps that eventually became Cloud.com, which eventually got sold to Citrix. But this was a time when AWS was still really small. They still had not yet even announced their earnings numbers. They were still less than $1 billion. There were a lot of people in the open source space who were trying to figure out, can we build an open source alternative to what's going on there? And there was also a number of companies and a number of people who were trying to figure out, maybe it's time for an open source alternative to VMware. And so you had all these things going on. You had some alternative approaches to doing this. You had, some competitive threats in terms of what AWS was doing and what VMware had continued to do in the infrastructure space. But some groups got together. First, again, it was Rackspace and NASA. But then you began to see companies start to say, "Hey, this is interesting. We're gonna dedicate some people to this. We're going to start to look at it. We're going to start to explore it." And you really saw every company in the enterprise that wasn't VMware start to jump on board. So whether this was Cisco or HP or Dell or Red Hat or Intel or kind of everybody and their brother, as well as a number of startups that formed out of formerly Rackspace people, formerly NASA people, a number of companies spun out of that. And so OpenStack was created. And the first thing the OpenStack community or communities had to figure out was, how are we going to govern these things? Because obviously there's a lot of people that have an interest in this, but their interests are all somewhat divergent, right? In some cases it was commercial. In some cases it was about building open source. In some cases, there was a very distinct rift in the OpenStack community of, are we building this thing to compete or replicate with AWS? Or are we building this to be a replacement or an alternative for VMware? And that rift was there very, very early on. And so they had to figure out, how do we govern this thing? How do we kind of keep all the factions and parties playing nicely together in the sandbox, if you will? And so what got created was what we're now very used to these days, an open source foundation. It was called the OpenStack Foundation. It was created. And initially it was maintained for the most part by Rackspace. The two initial lead people came from Rackspace. Rackspace sort of took a lead position in this, and I think a lot of that was because they were a commercial company. Obviously, they were trying to compete against AWS. That was where their interest lied. And so this was one of the early things that the OpenStack community probably didn't necessarily get right. They made their foundation not be really independent. It was still tied too much to sort of somewhat of a benevolent dictator. And people will argue, well, that wasn't exactly the case. There was different people working on working groups. But there was definitely a distinct feeling that the Rackspace folks have their thumb on the scale, and that, it's going to be a little difficult to figure out what we're building, especially if you're not directly aligned to what Rackspace is interested in. And this is where, again, you began to have some factioning of, are we building an AWS replica? There were a number of people at a point in time, people like Randy Bias and Simon Wardley, who said, this thing is fine. Actually, they were heavily involved with it at various stages, various companies. But they said, you absolutely, to survive, have to replicate and stay in sync with the AWS APIs. The only way this survives is to basically become an open source clone of the AWS APIs. Now, there was another faction within the OpenStack community who said, I'm not really interested in competing against AWS. At the time, they're not a very big company. I'm not even sure public cloud's going to take off, but I'm really interested in competing with VMware. And so there was a lot of people on that side of the fence saying we should focus on replicating VMware features, vMotion and those types of things. So, the first two things that sort of happened, again, not logically, but sort of in the bigger picture of things, was figuring out how to govern things. And they didn't quite get completely open governance worked correctly. They did to a certain extent, but not completely. And the other thing was they were sort of fighting a two-front war, and they didn't have commonality of purpose. They didn't necessarily, everybody agree that we're all rowing the boat in the same direction. And those were two things that really kind of fractured the community, if you will, and the projects as they were going on. Now, the next thing that OpenStack had to figure out was, well, okay, we have a compute project and we have a storage project, but what else do we need in order to build sort of a platform for infrastructure as a service? And they started looking at administrative things, control planes. They started looking at security. They started looking at other forms of storage like block storage and file storage. And over time, OpenStack started adding more and more projects, and we'll put some links in the show notes you can look at. And at any given time, there might be 8 projects, 10 projects, 12, 15 projects. And this is not completely unlike what we see in the Cloud Native Computing Foundation these days, where there's Kubernetes, and then there are lots of other projects around it, like Helm or Operators or Prometheus or lots of other things. But the difference was OpenStack initially kind of took this approach that you needed to be everything to be OpenStack. And this wasn't exactly what the market wanted. You had some fragmentation where some companies just wanted to go off and build an OpenStack storage project or an OpenStack storage product and build an entire company around that. Other companies wanted to be an OpenStack distribution. Some companies took a swag at trying to be an OpenStack cloud. And so, you had these various opinions on what was the thing that was OpenStack. You really kind of had to define what it meant. And again, this was an area that they didn't necessarily get right early on. It wasn't that they didn't necessarily get it right, but the market was too fragmented to necessarily get it right. And so there was a lot going on there. And then at some point in time, around later in 2011, 2012, and so forth, you started getting these other projects that came along. Cloud Foundry came along. OpenShift came along. Heroku had been out there. And so you had this push of PaaS is really where people should spend their time. That's where cloud computing is going. That's where developers are going. That's where we're going to make it easier for developers. We're going to build at the PaaS layer. The underlying infrastructure doesn't really matter. And so this is where you began to see the OpenStack community go, maybe we should expand out from beyond just IaaS and the multitude of projects that they were doing to try and build a really respectable IaaS to things higher up in the stack. And you started to see them start to try and build a PaaS layer that wasn't Cloud Foundry, it wasn't OpenStack, it wasn't Heroku, it was going to be something else. They started to think about, how do we get into building, data services, database as a service, Hadoop as a service? And you begin to have people question, are you building an IaaS? Are you building a PaaS layer? Are you trying to build everything? Is that possible in this community thing, especially when, again, going back to the question we talked about before, does everything have to be there? Can I only take parts of it that I want? If I take parts, is that still considered OpenStack? And so the community and the people running it, the leaders and the different working groups had to figure out, are we going to go with sort of a big build, if you will? Are we going to do something we consider sort of a big tent in which everything can be considered OpenStack, but you can take pieces and parts? And this is another area where you look at something like Kubernetes and the CNCF today have probably learned from what went on in the OpenStack days, right? They learned that there were going to be some core pieces you needed something like Kubernetes, but you could break things apart. If you wanted to use Prometheus all by itself, go ahead. If you wanted to just build operators, they probably were going to be used for Kubernetes, but that didn't mean that they could only be used for Kubernetes, right? We're seeing people use things like Kubernetes operators to represent cloud services, things in AWS or things in Azure or things in IBM Cloud or other places. So we learned a little bit about the importance of modularity through the things that OpenStack went through. So, again, some things they kind of got right? They were out there early. Some things they didn't necessarily get right. They were too fragmented in their focus. Some other things that they, got a little too ambitious for, right? They hadn't necessarily built a great IaaS product before they started trying to build all these other things. And again, this is from, different factions of the community, different groups wanting to try and monetize different things, had different focus, different background, and so forth. So all that was that. The next thing that people were always questioning was, where are the customers? Right? There are lots and lots of vendors. And every time there was an OpenStack summit, there were hundreds of people, then thousands of people, then thousands and thousands of people. But you looked around all the time and you were like, so many of these people are vendors. They work for the vendors. They work, they're talking to each other about OpenStack and they're all learning about it. But where are the customers? Right? This was an area that, again, the OpenStack Foundation didn't necessarily get right. They didn't focus on, how do we highlight customers that are using this? How do we make sure that the product and the technology is easy enough to use for customers, right? It was all written in Python. That wasn't necessarily a language that infrastructure admins were familiar with, right? They had to learn Python and they had to learn how to deploy Python and they had to learn how to deploy OpenStack and all these things. So they weren't necessarily super customer focused. They were super focused on building companies, taking VC funding, getting, being the lead of a lot of projects, but the customers were missing. And for the first couple of years, you understood that, but over time you were like, this isn't going to be sustainable if there are no customers. And that really came to a head around 2015, the OpenStack Summit in either 2014 or 15, the one that was in Austin, Texas. And you looked around and you were like, there are 7,500 people here. This is the biggest show ever. And there are so very few customers here. But one really important thing did happen there, and this is what's ultimately saved OpenStack, although it's taken it out of the mainstream eye. Nobody talks about it as being a VMware replacement or a AWS replacement anymore. But it became the technology that was going to be used by telcos. Right? It was going to be used for NFV and edge computing and other things that were going to turn cloud infrastructure, load balancers and firewalls and VMs and all those types of things that the telco community was just now beginning to move away from hardware into software, and they were looking for a way to customize it. They were looking for a way to have it at a lower cost through open source. And so around that 2015 time, the projects really shifted. The focus of the companies that were in this space really shifted, and it really became telco technology. And going forward, it's done well in the telco space. If you don't follow the telco space, you may not be familiar with it, but it's done very, very well in the telco space. A number of companies who had been active in that space either got acquired or they went away. It's obviously narrowed down to a much, much fewer number of companies that support OpenStack and contribute to it. but it's still very, very viable. They're up to their 20th, 21st, 22nd, 23rd release. So it's been around for a long time. It's sustained itself for an entire decade. But the lessons that we learned from OpenStack are, number one, if you're going to be open source and you're going to be part of building communities, you got to get governance right. And you got to make sure that the governance is transparent and that people feel like they can trust the overall governance, that there's a chance for them to contribute, a chance for them to participate, a chance for them to monetize if that's what their goal is. Number two, you have to have a good amount of commonality of what people are trying to solve. What goals are they trying to solve, right? This is where the fragmentation in the OpenStack space really kind of hurt them. In the Kubernetes space, we learned a lot from that, and that's been much more focused on building cloud-native applications and new applications, application modernization, less about trying to kill one company or trying to kill another company. And then the third thing was, you got to have customers. And that sounds dumb because, in any business, you got to have customers, but you needed to put customers first and foremost. You needed to make the technology usable for them, upgradable, scalable, deployable. And so you needed to focus on that, and you needed to make sure that once you started having customers, that they were going to be visible, because that draws other customers in to begin to understand that it's viable. They're people they can communicate with, not through vendors, but directly. Communities of interest can form and so forth. So those were the really big things that we saw was, it started off with a lot of promise. There was a lot of money pumped into this space. There was a lot of interest, a lot of articles written. There was a lot of buzz. But ultimately, those three things really kind of, were big kind of stumbling blocks, if you will. But the good news is it found a niche. It took 5 or 6 years to sort of find its market, find its focus area, find its way of being governed and organized. So that's good, right? Sometimes technologies just completely fail out. OpenStack has found a place in the telco world for the most part. There are still some enterprise deployments, but very much it's thriving in the telco space. And number two, we learned a lot in the open source communities. Kubernetes probably being the biggest learner of that. We've seen a number of people who have migrated from the OpenStack space to the Kubernetes space, but they've learned the lessons of foundations and governance and openness. They've learned the importance of focus on, what are we trying to solve? What problems are we trying to solve? How can we make that a big enough problem that not only the market really wants that, but there's a lot of space for a lot of companies and a lot of developers to thrive in and bring new ideas. And then ultimately, how do you make sure that the marketplace understands that this is something they can use, that you can highlight them, that you can make it easy to use and make it widely deployed? So with that, I'm going to wrap up this Sunday perspective about what happened with OpenStack. Hope you enjoyed it. I hope you learned something about it. Hopefully, the reason I put this together was to look at, what did we learn over the last decade? And did we take the things that we learned, both learnings as well as mistakes or failures, and have we moved forward with those? Because if we're not learning and being able to make changes to our mistakes and learn from our mistakes, then we're not moving forward. But I think we have as a community. I think, if we look at the broader open source communities, there's a lot more change going on that's happening. We'll cover that in future shows. But, OpenStack was a pioneer at its time. It got some things right. It got some things wrong. And hopefully for those of you that lived through it, you learned a lot from it that you've taken forward and you're now making better going into the future. So with that, I'm going to wrap it up. Thanks to everybody who's listening to this Sunday Perspective show. And with that, we will talk to you on Wednesday next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.